Hello, one and all present here. This is Amit Kumar Singh. Welcome to my class on probability. In this class, we'll discuss problem on Bayes theorem. So, Bayes theorem is basically it's a concept of inverse conditional probability. Okay, so you know about conditional probability. You know, right? When we are talking about conditional probability, we'll generally represent what is the probability of A dash B, where what is the probability that event A will happen, knowing that B has already happened. So we represent this with a formula called probability of A intersection B by probability of B. So this is the concept of conditional probability. Okay. So if you are not much aware about conditional probability, you can go through my videos on conditional probability that will give you a lot of knowledge about how the conditional probability basically works. Okay. So you know about conditional probability. You should also know about independent events. So when the events are independent, then probability of A intersection B that will be equal to probability of A into probability of B. So these are basic concepts of probability which you must be aware about. Now, when we say Bayes theorem is basically it works on inverse conditional probability, where whenever we'll see the problems on Bayes theorem, inverse conditional probability. So when you see the numericals, you'll understand. Generally, when we work on probability numerical, we try to work on the scenario where they ask us like they'll give us a scenario that there's a bag which contain these many balls of red, yellow, green, and then they ask us what is the probability that you get a green color ball, what is the probability you get a black color ball given that the first ball is green, something like that. But when we do the problems on Bayes theorem, in the Bayes theorem, what will happen in Bayes theorem? They will give you the output. Okay. So, and then they'll ask you what is the probability this output is done from this way. Okay. Like if you see this example one, there's a bag one which contain four white. There's a bag one which contain four white and six black ball. And there's another bag called bag two which contain four white and three black ball. Okay, so two bags are there. You can see this like you have two bag one and bag two. Okay, bag one contain four white, okay, and six black ball. Fine, and black two contain four white and three black ball. So bag one you have 10 balls, in bag two you have seven balls. Okay. And then one ball is drawn at random from one of the bag. Okay. So what is the probability that you choose bag one? What is the probability that you choose bag one? Or what is the probability that you choose bag two? That will be one by two, because both are equally likely to happen. Okay. You can either choose bag one or bag two. Okay. So what is the probability that you choose bag one or bag two? That would be one by two. I hope you are getting it. Okay, then if I ask you what is the probability that you choose a white color ball from bag one? Okay, I hope you're getting this. So that would be 4 by 10. Okay. If I ask you what is the probability that you choose a black color ball from bag one? So that would be 6 by 10. This is all you should be aware about. Okay. So what they are giving you in the problem, they are telling you that one ball is drawn at a random from one of the bag. So you have two bag. The probability that you choose bag one or bag two, that is one by two. Okay, you choose one of the bag. Okay, that is given to you in the problem, that you have chosen one of the bag and it is found to be black. Okay, so sorry, you have chosen one of the ball, okay, and you found black color ball. The probability that you get a black color ball from bag one, that is 6 by 10. The probability that you get a black color ball from bag two, that would be what? That would be 3 by 7. Okay, that would be 3 by 7. That will be 3 by 7. That will be 3 by 7. So you would know this, right? So what they're telling you, that two bags are there, okay, and they're given you that bag one contain four white ball and six black ball, while bag two contain four white and three black ball, and you got one ball and that ball is black in color. Okay, that you know. Okay, that you got a ball which is black in the color. Now the question is that what is the probability that it is done from bag one? I hope you understood this. So this kind of problems, when we discuss these kind of problems under Bayes theorem. So to solve this, okay, so let E1 is the event of choosing bag 1 and E2 is the event of choosing bag 2. Okay, and let A is the event of drawing a black color ball. I hope you understood. These are self-explanatory. Okay, then you this part already I cleared you. E1 is the probability of choosing bag 1. E2 is the probability of choosing bag 2. Both would be 1 by 2. And A is the event of choosing black color ball. So probability of A by E1 means probability of drawing a black color ball from bag 1. So that would be 6 by 10. Similarly, the probability of AE2 is probability of drawing a black color ball from bag 2. That would be 3 by 7. Easy thing, right? So this is the formula of Bayes theorem. This is the how we work on Bayes theorem. So they have given that you got a black color ball. That is already given, and A is the event which signifies that you are drawing a black color ball. Okay, the event of drawing a black color ball is A. Okay, so what they are asking you that you got a black color ball, that is already given. So I you should know the basic concept of conditional probability, how we represent the data in the form of conditional probability. So A is already given to you. Event A is already given that you got a black color ball. Okay, what is the probability that you get this black color ball from bag 1? That is the question. Okay, so how will you do this? So this is the formula of Bayes theorem. Probability of E1 by A is equal to probability of E1 into probability of A by E1 divide by the total outcome. Okay, so this is how we do. So the probability of E1 and probability of E2 is both 1 by 2. Okay, probability of choosing a black color ball from bag 1, that is 6 by 10, and probability of choosing a black color ball from bag 2, that is 3 by 7. You just put everything in the formula, you'll get the answer. The probability of drawing a black color ball from bag 1, that is 7 by 12. What is being asked to us? That because already given the problem that you draw a ball and that ball is black in color, what is the probability that ball is taken from bag 1? So this is how you work. So this is another example. This is very similar to the question what came in your uh, what you call model paper. So in the model paper, the this is the question. You can see question number 2. This question came for 10 marks. You can see this question number 2. So this question is very similar to the problem which I'm discussing right now. So in a bolt factory, there are three machines are there: M1, M2, and M3. You have three machines. Okay, they manufactures 2000 units. This one manufacture 2000 units. This one manufacture 2500 units. This one manufacture 4000 units. Okay, then total you can say you have 8500 units. Okay. So what is the probability that you choose machine M1? That would be 2000 by 8500. So that would be 4 by 70. What is the probability you choose machine M2? That would be 2500 divided by 8500. That will be 5 by 70. Okay. Then what is the probability you choose machine M3? So that would be 17 minus 9. That would be 8 by 70. Okay. Total probability is 1. You understand? Okay. So these are the units they manufacture. Machine M1, M2, M3, 4000 by 8500. In case if you do not understand. So three machines are there. They manufacture this many bolts. So the probability you choose machine M1 is 4 by 17. You choose machine M2 is 5 by 17. You choose machine M3 is 8 by 17. Okay. And then out of the output, 3%, 4%, and 2.5% are defective. Okay. So what is the probability that you choose a defective component from M1? Okay. That is what 3%, right? That is 3%. Okay, probability that you choose a defective component from machine M2, that would be 4%. Probability that you choose defective component from machine M3, that would be 2.5%. Clear everyone? Then one of the bolt is drawn very randomly from day production and it found to be defective. So you got one bolt and that is defective. So you got a defective bolt. What is the probability it is from machine M2? This is your question. So how will you do this? This is very simple. What is the probability that you choose a machine M2 into probability that you choose defective component from machine M2 divide by total probability of choosing any machine. Okay, how many machines are there into probability of choosing defective component from that machine. Okay, where you have from 1 to 3 machines. Clear everyone? So this is how we do. Probability of choosing a what is probability of choosing machine 2 if you got the defective component? That is the question. Probability of choosing machine M2 is 5 by 17, right? 5 by 17 into defective component from machine M2 is 4 by 10. Divide by each one you have to do. First is 4 by 17 into 3 by 100. If I'm not wrong, 3 by 100. Then second one is same thing, 5 by 17 into 4 by 100 plus what? The last one is 2.5%, right? Then it is 8 by 17 into 2.5%. You just solve this. This is what 20 by 1700 divide by 12 plus 20 plus 8 into 2.5, that would be 20 by 1700. This would be 20 by 62. This would be 10 by 31. Clear? Okay, 52, not 62. This is 20 by 52, not 62. This 20 by 52, or this would be 5 by 13. 13 fours are 52. Okay. Now this is a question, 10 marks question. A factory has three machine M1, M2, M3. I'll really request you that you can pause the video and you try this question by yourself. A factory has three machine M1, M2, M3. They produce 4,000, 10,000, 6,000 products per day. From the past record, it is known that machine M1, M2, M3 produces 5%, 4%, 8% effective component. A product is selected random from day production and found to be defective. What is the probability that is not produced by machine M2? So if it's not produced by machine M2, it can be produced by machine M1 plus M2. Okay, not produced by M3, they're asking you. So here I'm just introducing M1, M2, M3 denotes the event that the randomly selecting bolt from the day production. Okay, from M1, M2, M3. Okay, so by machine M1, M2, M3, and X is the event. Suppose X is the event that the product is defective. So the probability of X by M1 means you get the defective component from the machine M1. That is the probability. X by M2 means probability of getting a defective component from machine M2. Probability of X by M3 means probability of getting a defective component from machine M3. So you know that you have 4,000, 10,000, 6,000, 4,000, 10,000 and 6,000. You have 20,000 units. Probability, what is the probability? You can calculate the probability. This would be 4 by 20 or 1 by 5. This would be 1 by 2. This would be 6 by 20 or 3 by 5. 6 by 20 or 3 by 5. 3 by 10. 6 by 20 means 3 by 10, not 3 by 5. This is 20%. This is 50%. This is 30%. Fine. So Once you get their probability, okay, then what is the probability of getting a defective component? Okay, 5%, 4%, 8%, 5%, 5%, 4%, 8%. That is the probability of getting a defective component. Defective component. Okay, if a product is selected random from the day production and it found to be defective, what is the probability that is not produced by M3? What is the so a product is found to be defective, is found to be defective. Okay, okay. So they're asking you what is the probability? What is the probability that it is not from machine M3? Not from machine M3 means probability that it is from machine M1 or machine M2. Either you find this. Okay, this is the one way. Okay, they are all are mutually exclusive events. So this is nothing but probability of machine M1 plus probability of machine M2. You can do this. Okay, and other way, what you can do, 1 minus the probability that it is from machine M3. Do whatever, both will give you the same answer. Okay, let me do this way. So what is the probability that this is from machine M3? Let me first find, what is the probability that the defective product is from machine M3. Probability that the defective component, you got the defective component which you got being found is from machine, is found is from machine M3. Okay, so how will you do that? You got a defective component. What is the probability that is from machine M3? That would be probability of getting machine M3 into probability of getting a defective component from machine M3 divide by total probability. Probability of choosing machine M1 into defective component from M1 plus probability of choosing M2 into defective component from M2 plus probability of choosing M3 into defective component from M3. You do like this, you will get the answer. You know probability of choosing M3 is what? 30%, right? 30% is the probability of choosing M3 into defective component from M3, that is 8%. That is 8% divide by uh, M1. M1 was 20%. 20% into 5% plus 30% into 8% plus this is third, no? 50% into second one is 50% into 4%. Just do this, you will get the answer. Ignore this, all will cancel. This percentage will get cancelled. This is 240 into 10 to the power minus 4 divided by this is 100 plus this is 240 plus this is 200 into 10 to the power minus 4. This is an all percentage will get cancelled. You can ignore 240 by what? 245, 540. So this will be right. Go by 6, 6 fours are 24, 6 nines are 54. You'll get 5, 4 by 9. So probability that it is from machine M3, that is 4 by 9. Okay. So it is not from M3, that would be 5 by 9. Let me just check my calculation. Yeah. So probability that it is from machine M3, that yields 4 by 9. Then what is the probability that is not from machine M3 means it probability that it is from machine M1 or machine M2 because they are mutually exclusive. That would be 1 minus 4 by 9. You will get answer as 5 by 9. Clear everyone? Very simple problem. I hope you understood this. This problem is very important for your exam purpose. Thank you everyone. Bye.